Hi, this is Matt Hitchcock, Singapore PowerShell User Group Lead. I wanted to give a quick introduction to the upcoming video because we had to edit out the whole beginning due to multiple audio issues that we had. So the video you're about to watch is a presentation for PowerShBreakfast number 3. I would like to extend our thanks to our sponsors, Microsoft and Sapien Technologies, for their support in making these events happen. If you would like to check out WMI Explorer and PowerShell Studio from Sapien, there are trial downloads available from their website. To introduce PowerShBreakfast, it's a linked meeting that we run every month. We run it on a Saturday morning at 8:30 AM Singapore time, and it's online so that people are able to join us from wherever they are to talk a little PowerShell without us intruding too much on their weekends. Weeknight meetings are typically harder to run here due to the work patterns people have, but running it at this time also gives us a really good time zone overlap with the US, which gives us an opportunity to get some good guest presenters on. Our presenter today is Adam Driscoll. Adam is a developer from Dell and a PowerShell MVP. He's written and contributed to a number of books, and he also has some PowerShell projects available to download, which I'll provide you some links to later. So it was a real pleasure to have him on and present him for us. Before I hand over to Adam, I just wanted to take a moment to talk about what's next for us and share some resources. You can see from the slide any links you might need to connect with our group. If you'd like to sign up to the mailing list, please visit our Facebook page and there is a mailing list sign up option. If you've attended or registered for one of our events in the past, you'll already be on this list, so there's no need to sign up again. I would encourage everyone to make sure that our email address is on your safe senders list, however, to make sure that every email arrives. So as for those future events, the dates are yet to be confirmed, but at the moment they look like this. So at our next PowerShBreakfast meeting in August, we are going to have Stephen Morawski from Chef talking to us about DSC. Stephen's probably the most battle-hardened person in the world with desired state configuration. He's implemented it in production at Stack Exchange, so it's going to be really great to have him with us. Then following on from that, we'll have our usual PowerShell Saturday in August, where we'll continue along with the DSC theme, and we'll have some hands-on sessions going there as well. So the usual workshop format we're used to. And then on our PowerShBreakfast meeting in September, you'll have me talking about how to supercharge your PowerShell ISE with various available add-ons. And lastly, I would like to share some links to some very useful resources, and particularly encourage you to check out the 2 videos on the Microsoft Virtual Academy. Whether you're new to PowerShell or not, I'm sure you'll find them very useful. There are also links there to all of our past content, and there's a link to the PowerShBreakfast website as well, where all of these presentations will be published. So with that, I'll hand over to Adam. Enjoy the video. Try from over here. Over here?
What better?
Okay. Even over here I can hear it echoing. And I'm outside. Right, okay. I've had to leave the room because we're having some audio problems. So I'll just introduce it and then I'll head back in. So, Adam, I can't really hear you very well again, but maybe that's my... So For the guys in the room, can you hear Adam okay? I'm not hearing anyone else, actually.
Hello? Hello?
Ah. Can just about hear you now. Okay, so Milton says that the quality is okay, I think. So if you're ready, Adam, then we'll kick off, I guess. So welcome along to the third PowerShell breakfast meeting. Even though I'm outside the room, I can actually hear me echoing, and it's really off-putting while I'm talking, so I'm going to walk a little further away. So welcome welcome to today's meeting. Our guest is going to be Adam Driscoll, PowerShell MVP, talking about unit testing. Welcome, Adam.
Thank you.
Thank you.
Can't complain.
Good. We can. We got so much happening here that's going totally wrong. It's unreal. But okay. So yeah, I'll hand over to you then, and you can go ahead. Someone needs to make you a presenter, though. I think I can do that. Or Milton might need to make you a presenter, actually. Yeah, cool. All right.
All right. So yeah, just stop me again if you don't hear me for whatever reason. All right. So my name's Adam Driscoll. I'm going to be talking about unit testing in PowerShell today. So I'll just tell you a little bit about myself. I'm a manager of software engineering at Dell. I work on a product called vWorkspace. It's kind of like a Citrix. All right, awesome. It's very similar to what Citrix does in terms of delivering applications and desktops to end users. That's kind of where I got my start in PowerShell. We actually just developed the PowerShell module for that, and from there I've actually kind of taken to it. So I'm a second-year PowerShell MVP. I really dig it. I did a lot of stuff around system internals and stuff like that before this, and right now I've been working on the PowerShell tools for Visual Studio. That's my big pet project at the moment. And if you ever need to get a hold of me, Twitter is the best way. I would definitely say to follow me on Twitter and just get a hold of me. All right, awesome. Today we're going to be talking about unit testing. So first of all, what is unit testing? Unit testing is writing code to exercise your code. It ensures that your code is doing exactly what you intended it to do. And the idea behind unit testing is to test the smallest snippet of code that you can. So you assert on very specific points in your code, and then you have like one assertion per test. That way you can easily identify which parts of your software are breaking based on which tests are failing and passing. Unit testing has been a part of software development for quite some time now. Pretty much we have CI environments or continuous integration environments where when we check in our code, all our tests are automatically run and the build will actually fail if any of those tests fail. So the idea here is that you increase the quality of your code based on the number of unit tests you have. I was going to keep checking this just to make sure we're good. I'll just keep checking. I have a lot of unit tests. Unit tests make up the foundation of the pretty much the test pyramid that we kind of go by. Unit tests, you have the most of them. They're very reliable. They're very low cost because you can write them while you're actually developing the code, and they provide almost instantaneous feedback. And as you go up the pyramid of testing, you go from component tests, integration tests, to user acceptance tests and system tests. And obviously, user acceptance tests and system tests, they take the most resources. you have actual people trying to test these things or large systems, the feedback might be days, if not weeks, and it's very costly. So that's the idea behind unit tests, is to catch the small problems early. So that brings me to why we unit test. And unit test to, let me just make sure, cool. Why we unit test is first to find issues early. If you have the person that's writing the code, writing these small little tests to guarantee that the particular code is working the way it should, then you can catch it almost instantaneously. Obviously, you can't catch everything in a unit test, but it does give you a lot more confidence in the code that you're writing. And this is kind of the idea behind catching it early, is the later you catch a defect, the more cost it's going to be to repair it and get production fixed and all that kind of stuff. So when you find a defect in service or at a customer site, it's very costly in terms of manpower and just debugging. You have like support engineers involved and all that kind of stuff. But if you can catch that bug early on in unit testing, it's a minuscule cost to you. Some other reasons we unit test are to increase the confidence in code change. So if you have a large suite of tests that ensure that your code is running the way you think it should be running, then when you make changes to that code, you can just run your tests, and without having to roll it out to production and all that, you can just run this suite of tests to validate that that particular code change did not break the pre-existing functionality of that function or module or whatever you're testing. A couple other things include improving integration and aiding in design, because as you're writing tests while you're developing, it kind of makes you code in a way that makes you think about how other people are going to be using this particular functionality. So rather than kind of having that as an afterthought, you're thinking about that as you go. So it kind of helps you design it a little bit more from an end user perspective than you would normally. Sometimes you just want to get the job done and you want to just churn out some code, but this kind of helps you make it a little more elegant. It's also considered living documentation, because we all know the last thing to ever get written is documentation. So the big problem with documentation is trying to keep it up to date with what's changing inside the product. So the same thing holds true for scripts. You might have wrote a bunch of comments at the top of your script, but they just might not apply anymore. But if you've written a big suite of unit tests, it provides real living examples of how to use the function that you just wrote. And you can run those tests to actually exercise that function. And if something's changed in the function in regard to the test will break, and then we know that that function no longer behaves that way. So then you could either fix the function or the test, and from there you kind of have this documentation that you can go off of. So you can kind of think of it like a living get help examples. And, that's what unit tests can be used for as well. In traditional software development, there's kind of two big testing methodologies that have come out in the past X number of years, and that's test-driven development and behavior-driven development. First of all, there's test-driven development, which is the idea that you write your tests before you actually implement the code. So it's kind of an interesting concept, an interesting way to tackle the problem. The idea here is that you have the test there so that when you go to actually write the code, you can validate immediately whether or not what you wrote is what you expected to happen. So the first thing you do is you write a test that fails. I'm writing a new commandlet, a new function. I'm going to write a test that just validates the very bare minimum of what that function should do. Once I have written that particular test, then I can go out and implement it until the test passes. So you make the code work. From there, you can refactor. So that means to change your code in a way so it's either easier to understand, eliminate redundancy, increase maintainability, that kind of stuff. And since you have this test already in place, then it kind of, again, it ensures that you have the confidence in the code change. So then you iterate rapidly. You write a failing test, you make the code work, you eliminate redundancy. So red, green, purple is kind of the idea here. You're just going round and round, red, green, refactor. So it's a really good way to go. It does take a little more overhead up front because you are writing all these tests, But by the time you're done with your particular function or functionality that you're writing, you have a big suite of tests that you can then commit to whatever source control repository you're using for the next guy. So when someone else comes along to change that function, you already have that suite of tests there that you can execute, and if they change anything, they can see if they broke it, something, and all that kind of stuff. Kind of along the same lines is behavior-driven development. So the idea here is the business stakeholders and the technical stakeholders are typically two different people. Business stakeholders typically don't have the same technical knowledge that the technical guys do, and the unit test might just not make any sense to someone outside that particular area of work. So there's kind of a funny cartoon that always floats around software developers. This is kind of how all the different people in business interact. You have how the customer explained it, and the project leader understood it. I really like how the programmer wrote it, because it's just sitting on the ground. And then how it was documented, you can see there's a good reason for unit tests, because there's just nothing there. How the customer was billed, they built a roller coaster, that kind of thing. So this kind of miscommunication is one of the reasons behind BDD. So the idea here is that when we're actually writing tests, let's check the comment. Yes, I like it. It's really funny. All right. So the idea here is that we're bringing the business heads into the technical world to kind of ensure that what they're explaining to us is what we're building. So in the agile methodology of software development, there is the concept of user stories, which pretty much is a definition for a particular new feature. So, for example, the business guy might be like, I want all my servers to turn off on the weekend to conserve power. So that would be a user story. So as an owner of this business, I want all my servers to turn off on the weekend so that I can conserve power. That's kind of how it's written. And from there, what you do is you actually write acceptance tests. And the acceptance tests, you work with the other stakeholders, the non-technical stakeholders, to determine what those acceptance tests are. So, I want my server, the server should turn off at 9 a.m. on Saturday. That would be one acceptance test. And then you have another acceptance test. The server should turn back on Sunday at 9 p.m. So then, from the business perspective, they can actually go and see that the code that has been executed is, completing or passing these acceptance tests. So you still write unit tests, you still iterate, you still do red, green, refactor, but you also have this concept of acceptance testing on top of that, where the business stakeholders ensure that they're getting the correct functionality built out of whatever you're doing. So that's kind of the idea behind behavior-driven development. So it's another kind of interesting concept. We personally don't use it in business. You got to be kind of pragmatic about it, but I can see where it definitely has its place. I'll just keep going. Let me know if I should stop. All right, so here's I'm just going to kind of go over the anatomy of two different types of unit tests. First is a traditional unit test, and second is a BDD unit test. All right, first of all, we'll look at a traditional unit test. This is actually a unit test right from from our product. I actually opted to use PowerShell unit testing over C++ unit testing to actually test the C++ service that we have. Rather than using one of the kind of difficult to work with C++ frameworks, I decided to kind of take advantage of the PowerShell. You guys hear me? Okay. I got dropped there for a second. Yeah, that's okay. You think with all this fangled technology, we could present easier. All right. See my desktop. Cool. Yeah, just stop me if that happens again. Yeah, I'm not really sure what's the best bet. I've heard that Google Hangouts works better than Link, but I don't know. Sometimes Link seems to work okay. All right. All right. You hear me? All right. Yeah, I guess so. All right. We'll try this again. All right. So, all right. Cross your fingers. All right. So the idea here is you have a test fixture that tests an individual component and either module or function or something like that. From there, you have a test setup, and the test setup is actually run for each one of the test cases. It configures the environment however you need to for this particular test, and typically it just kind of shortens the test cases into smaller units so that you don't have to run a bunch of code in each one of the test cases. From there, you actually have your individual test case. Each individual test case should be as small as possible, and typically, if you're being a purist about it, it should assert on one thing and one thing only. So in this case, I'm ensuring that our particular function call here, get website settings, returns a valid site, so some XML to configure our website. And you can see it's just one line. It ensures it, and then you can fill your test fixture with as many test cases as you want, and each one of them will have the test setup run and everything like that to test all different avenues throughout your code. From there, then you actually have the test teardown. It just does the opposite of the test setup. In this case, it's removing some stuff from the database, stopping the service that I'm testing, and uninstalling my database connection. So it's pretty straightforward and just kind of exercises your code in a structured manner. EDD world, the whole idea is that you can kind of read it like English. So in this case, we're describing how a new document should work. In this case, we have a context. So when no document exists, it should create a new document. So that's kind of how it reads. And then you could, define all the different acceptance tests that meet that description of new document. So it does the same thing as the traditional unit test. It just reads a little bit differently, and it's set up a little bit differently. So you have an additional node here for the context. This is actually using Pester, and as you can see, there's no teardown or setup blocks. You can just do stuff before and after particular contexts or it blocks within the describe block. All right, so that's kind of the difference between the two different types of unit testing styles. Another big concept in unit testing is asserting and mocking. So an assertion is just validating that your test returns the values that it should be returning. Both big unit testing libraries in PowerShell have assertion libraries or functions that you can use to assert that your functions are returning values or throwing exceptions or not throwing exceptions based on the input that you're providing it. And they also read like English, so I'll show you some examples of how it just reads like pretty much you can read it, any person could read it, and it just literally looks like English. Kind of a concept you might not be familiar with is the concept of mocking. So mocking is the ability to isolate your units from outside services or dependencies. So, especially with PowerShell scripts, you're accessing a lot of things outside your PowerShell script. You might be talking to WMI or invoking SQL or talking to some, Microsoft product like SCCMM or something like that. And they all have their own commandlets. And then rather than actually, running your tests against these systems, you can run your tests and isolate them from the systems themselves. So the mock will actually replace those function calls, and you can return whatever values you want from those mock function calls. And this allows you to just execute your code and your code alone. There's a little caveat with mocks. You have to be a little bit careful because it kind of gives a false sense of security sometimes. When you actually go to integrate your code, a lot of times the dependent modules and stuff like that might behave differently than you're expecting. And if you've mocked away all the things that you typically do, you can run into problems where you actually go to integrate it, and even though your unit tests are passing, it's not necessarily the best test because you've mocked away pretty much everything that you actually are doing. So you just got to use it, pragmatically. So you got to think about it. Does this make sense to mock this, or is there some other way I can do this that makes it a little safer? So it's just kind of a design thing. All right. So the big unit testing tools inside the kind of PowerShell world are Pester and pstate. So Pester is the one that I'm going to be talking about a little bit today, and I have some examples of pstate as well. The nice thing about Pester is it integrates everything. It's a framework. It provides mocks. It provides all the assertions, and recently, I think as of today, they added code coverage, which I'll show you guys that today as well. Pstate, there's also psmock and pshould. They all play together with pstate. And it does the exact same thing as Pester, and there's some benefits to either one, and I'll talk about that a little bit. And glad you think so. All right, so I'll talk about the little differences between those two, and then I'll show you guys some examples and stuff like that. All right, so enough of the slides. Let's jump into some PowerShell scripts. So I just have this little module here, a little collection of functions, I guess, for automating Microsoft Word. You guys still see me? It flashed. All right. I have this little set of functions for automating Microsoft Word. So the idea here is... Yeah. Better? I can make it even a little bit bigger, probably. Yeah. Didn't change. About 200% now. Is it any better or no? Yes, no, maybe so. Oh, that's weird. Is my screen frozen? It looks like it. One second, let me try resharing my screen. I think it was stuck there for a second. All right. How about now? All right. Maybe I went a little overboard. All right. So like I was saying, this is just a module that does some. It's all good. All right, cool. This is just a module that, or just a collection of functions that I have for kind of automating Word. So you can actually automate any Office application, and you can access them via COM objects. So you just use new object, specify the COM object, and then all the prog RDs are like Excel.application, I think PowerPoint.application, and Word.application. So this just instantiates a new version of Word pretty much, and then I've wrapped some of the functionality into some simple functions. This one creates a new document. This one adds some text. This one gets text, and this one actually closes Word. So pretty simple and straightforward. Nothing too crazy going on. But what's nice is I have a whole set of tests written. So first we'll look at some p-state tests. So these tests are written in the traditional format. These are using the test fixture, blocks, test setup, and test cases. So as you can see, I have some Word tests here, and I've written them kind of in the BDD fashion where you're saying should, create new document, should add text, but really they're in the traditional unit testing sense. So if we go ahead and actually run these tests, what I'm going to do is you can see Word flash a couple times. It opened up Word, it added some text to it, and down here in the debug view, I should probably, you guys read this might be a little small. Okay, so this is the actually output from running the test. You can see that this is the first fixture that I ran, Word tests. Something is returning true that shouldn't be, so that's like actual output from the test. This is the actual result of the test. Uh-oh. I think the screen might have just flashed and it's stuck now. Or not. No? Okay. All right, so the actual first plus here, case should create new document, actually passed. So that's what the plus indicates. And you can see it ran for 351 milliseconds. In the case that there's a failure, what you'll see is a minus. And the minus means, this test failed. It ran for 701 milliseconds. And then it gives you the reason for the failure. So we were expecting some text, but we actually received some text. And it looks like there's like a carriage return here at the end. And that's the difference. So that's why the test failed. So it's looking for exact inputs and outputs pretty much. And it's doing that using these assertion keywords. So you can see it just reads like regular English. So get text, you pipe it into should, and it should be some text. So there's all kinds of assertions that you can do. You can say, should not be, should not equal, should be in list sort of thing, all that kind of stuff. Should not be null, that's what it's doing up here. So in this case, we can actually go off and fix our test by adding a new carriage return to it. It's nice. Then we can just run our test again. You can see it popped Word open a couple times, and now you can see our test is passing. So that's really cool, because now I know that those functions that I wrote are working as expected. But let's actually go out and develop a new function, or add some functionality to one of the functions that we have right now. So first, we're going to do it in TDD fashion so that we write our test first. So what I want to do is I want to add a parameter to add text to actually set the font size. So should set font. So I'm going to create a new document in this test. And I'm going to call add text. We can add some text. And then we're going to say font size. So that parameter doesn't even exist. But we're going to put it in there anyways. And then we're probably going to have to create a new commandlet to actually ensure that that font size got set correctly. So in Word, pretty much what you do is you select part of the text inside the Word document, and then you can check the size of it. So let's actually go ahead and create a get selection commandlet. And from there, what we can do is the selection object actually has a font property, and the font property has a size. And I'm cheating because I know all this already. And we want it to be 14. So as you can see, this test is validating that I can set the font size. When I get the selection of the current text inside the document, that font size will be 14. So if I run this, opens Word a couple times, and you can see the last one failed. And it failed for exactly the reason we thought it would. Parameter could not be found that matches the parameter name font size. So let's go and adjust our function here to actually have font size. So we're going to default to a font size of 12. Just takes an integer. And then what we can do, you can see here, this is where I talk about the selection. So we grab the active selection inside the application. We call whole story, which actually grabs the entire documents as a selection. From there, we want to set the font size of that selection. All right, so now we can go back and run our test, and we're going to run our entire test suite again to make sure I didn't break anything else. So run some stuff, and you can see we got further along in our test. The term get selection is not recognized as the name of a commandlet. All right, so now we need to ensure that we have this get selection commandlet. So let's go back here and actually implement that quick. What I can do there is say function get selection, and I'm just going to grab the active selection. So nothing really to this commandlet. All it does is just return the current selection in the application. So now when I run my test, I didn't mess something up for some reason. You can see that my test now passes. So I implemented it in a TDD fashion. All my tests still pass, and I added new functionality, and I'm confident that the code I changed did not break anything else because I already had pre-existing tests inside this particular test suite. So what's real neat about this is actually the P-state model over Pester is that you can just F5 run these tests. So Pester doesn't allow you to do that. You actually have to use an invoke Pester command. So I've always been kind of on the fence about which to use, but Pester adding code coverage, and it can do some other cool things. I'm kind of leaning towards Pester now, but I wish you could run tests this way with Pester. It just makes it a lot easier. So let's... Woo! That's great. You know, what's funny is I installed 3.0 today and I didn't even try that, so I might have to give that a shot right now. Yeah, so, where was I? Oh, yeah. I was going to show off the same test suite, but written in Pester and P-state. So, kind of taken from the examples of Pester website, this is the header that you have to put on there. Pretty much finds the test or the file that you want to run. So in this case, office.ps1 is what I'm dot sourcing into my particular ps1 file here. And you can see that this is a lot more BDD fashion. They have the describe blocks. So I want to describe new document. It has a context. When no document exists, I should create a new document, and that new document should not be null. So the assertions are very similar to P-state. It's just the other, kind of constructs that are a little bit different. Again, I have another describe block, but this one's for add text. It should add text. In this case, new document. It's the same, pretty much the same guts as my other test. And then finally, I have a closed word one, what I'll get to in a second, and kind of go over with how the mocking works. All right, so if I go ahead and run this, it should work according to Dave. It does! Oh, that is so awesome. All right, so as you can see, the output is very similar to what you saw in P-state. You have the plus, so it should create a new document. Describing add text, it should add text, sort of thing. In this case, you can see that we're in the describe block, we're in the context block, and then we're in the it block. And And you can have multiple if blocks inside your context blocks and multiple context blocks inside your describing block. And you can see I'm failing for the same reason that I was failing in the other test fixture, that I don't have that carriage return. So again, I can come in and fix that particular test to ensure that I have that carriage return at the end. So if I run that again, you'll see that hopefully my test passes. Certainly does. All right. So now I want to touch on mocking. So like I said, this kind of isolates your particular test from outside dependencies. In this case, I'm taking a dependency on get process and stop process in my close word function here. Oh. So close word just gets process named win word and then called stop process. So it'll just stop all the pretty much word applications that are running on your box. So in my test, I'm using the same constructs, describe, context, but now I'm using this other aspect of tester that is a mock. So in this case, I want to actually replace the functionality of get process with my own. So I say mock get process. This block right here is the script block that will actually return the value from get process. So in this case, I'm just returning an empty system.diagnostics.process that I'm creating with new object, rather than returning the win words that are running on the system. And then here is a parameter for actually filtering parameters. So inside your test, if I called the get process and the name did not equal win word, it would not actually call the mock get process. In this case, if it does equal win word, it will call my mocked process and just return an empty process object. The next step here is to mock stop process, because that's the other side of things. I want to ensure that stop process is being called. In this case, I don't want to return anything from stop process. I don't care. It doesn't need to do anything. But I want to make it verifiable. What that means is making it so that you ensure that this particular function was called. So what you can do then inside your it block is actually assert verifiable mocks. So anything that you marked verifiable, you can then ensure that that verifiable mock was called. So the test will fail if stop process was not called for whatever reason. So right before my it block, I actually call close word to have it execute. And what you'll see is it'll actually pass because it's replaced the contents of those particular functionality, or those particular commandlets. So at first I was doing something like this, which is kind of interesting, and you'll see it's kind of cool because the mocks are pretty intelligent. And run my test. You can see that it was unable to actually call stop process because it does not accept a string through the pipeline. So that means that the mock has all the same parameter sets and all the parameters and all the validation, or not all the validation, but all the parameter-based validation of the existing commandlet. It's just you can replace the actual functionality of it. So that's pretty neat. So that's really powerful. I know that's kind of a crappy example, but I mean you can use this to stub out all kinds of things inside your modules. One thing I noticed is you can't use import module, I don't think. I think you can only dot source it. I was trying to do import module before and it was not working. All right, another really cool thing about tester correct, yep. Okay, yeah, I figured it had something to do with the scoping of it. Yeah, I didn't really play around with it too much, but it's good to know. I might have to dig into that a little bit, because I'm very curious. Okay, very cool. Huh. All right, good to know. Yeah, I guess because technically it's scoped inside that module. Huh. Play around with that. All right. So like I said before, the Pester has a few neat things that PSAID does not have. Dave probably knows all about this one, is code coverage. So what code coverage allows you to do is see how well your tests are actually covering the code that you're testing. So for example, if we went over to this particular test and, I don't know, what if we got rid of add text and get text in this test. And we ran it using invoke pester. What you can actually do is specify a code coverage parameter. The code coverage parameter then takes a list of files that you want to validate, or check how much your test is covering of those files. So in this case, we want to test office.ps1. So now if I run this, run my tests just as it would. Now what you'll get at the bottom here is you'll see that we have a code coverage report. Code coverage report says that I'm covering 35.71% of the 14 analyzed commands in that file. And it'll actually list out the different blocks that I'm not covering with my test. So those are probably all inside those functions that I commented out. So now if I go back and edit my test, which you call add text and get text, invoke this again, runs my tests, and now you can see I'm at 92.86%, so I'm covering most of my particular module. So code coverage is a really good indicator of pretty much how well your tests are covering your module. You got to be a little careful with the metric. We've kind of got burned in the past where we've had developers write crappy tests that just bump up the code coverage numbers. So you got to be, that's why you code review each other's code to ensure that that's not why that's happening. But it is a really good indicator of how well your tests are executing your particular code. Sometimes it's really hard to get 100% code coverage. We usually aim for around 90% in our lab. Usually that's a really good metric. So depending on what you're working with, it may be more or less. You just got to kind of, take it with a grain of salt. So the other really neat thing about using invoke pester is that you can actually specify an output XML file. So in legacy software development, there's been unit testing for a while, like I said. One of the first .NET based unit testing libraries was NUnit, and NUnit it got a lot of steam and everything like that. And what it would do is it would output these XML files in a particular format, and then from there, systems could eat them up and display them in a nice little fashion, like continuous integration build servers would build everything, run the tests, and then they could look at the XML output and maybe put it on a website or email it on the group, that kind of thing. So Pester actually outputs XML in the same format as NUnit, and what that does is it allows you to use all the cool tools that come along with the software development space, around NUnit. So I ran this test a couple times, and what it did is it actually output this test results XML file to my desktop. And I downloaded this little NUnit test result viewer from SourceForge, pop that guy open, and it can actually open up this test results file and display it in handy dandy little thing that isn't what it was before. Huh. I swear it worked before. Yeah, I didn't actually. I think that might be a bug in 3, Dave, because that worked. I was using the other version, I thought. Unless I'm missing something. Another thing is, I don't know if it overwrites the file. Let's try again. No, okay. I'll yell at him then. Yeah, it looks like the same output. So if this would have worked, it would have displayed it in this nice little handy dandy tool here. This is what you get for changing your demo right before presentation. But the idea here is that there are all kinds of NUnit tools out there. So you could actually run your PowerShell scripts on a build server just like you would any other software development tool, and get this kind of information back and get it displayed, like I said, in a website or an email or that kind of thing. So that's kind of the extent of what I wanted to go over today, and I kind of want to just open it up for questions because I know this is kind of new to the IT space. I think it's been around in software development for a while, but with the advent of Pester and P8, I think people haven't really dug into this as much as they could. So. I typically try, like I said, it doesn't always make sense to, write a unit test. Sometimes I'll the really good candidates for writing unit tests are when you have lots of little logic-y things going on, like if this and that. Right. So if you have a test, if you have a script that you run in production all the time, let's say, something that, runs all kinds of stuff against your system, rather than, the ad hoc things are probably not the things that you're going to test all the time. But it's the things that are, algorithm type things where you might be doing string manipulation or, you're parsing XML, that kind of thing is a really good candidate for testing because you're going to be running that script over and over again while you're trying to write it anyway, so you might as well run some tests to validate that particular script is working that way. I think a lot of times the integration type scripts might not be the best candidates, but that's where I was saying, you might just be mocking the world then. You might end up mocking every integration point that you have. Yeah. Right. Like Dave said, yeah, if you're going to save it and use it later, it's a good candidate too. So. Right. Yep. And that's where, the TDD and BDD thing is good to know, but I think sometimes, it does not start out as a giant script. And, it might not make sense to write your tests up front if you're not going to have this giant script. It's pretty simple. But like you said, once it starts getting big, then it could be a good candidate for that as well. Oh yeah, that's huge. Honestly, day to day, that's kind of what I do. We've been trying to cover more and more of our code. We have a lot of legacy code, and we can't change it with confidence. We have to spend hours and hours of QA work because there's no good way to confidently test it. So we've been trying to pretty much build out this big test suite so that we can confidently change things without having to worry about debugging bugs in the field all the time or even in QA. So. Pester does have a lot of good documentation right on the GitHub site if you want to go out there. There's a wiki. There's actually there's a video on how to get started and all that stuff. There's some examples out there and everything. So Unit testing in general, there's a lot of information out there, but it's going to be a lot more like C# based typically. But it's kind of the same concepts. Yeah, that code coverage thing is pretty cool. Maybe I'll have to bring it up to them. I don't even know if they do. I think PowerShell unit testing in general, a lot of people don't know about. It's kind of one of those things that I feel like more people should know about it, and I don't. And yeah, unit testing legacy code has been is kind of a sore spot, honestly. Typically, especially in software development, it's very difficult to unit test legacy code because it's just not designed in a way that makes it easy to test. And like I was showing before, where I have like a pseudo integration test where I'm running that service and I'm testing it with the PowerShell stuff. It's really not. It's really not a unit test. It's more of an integration or acceptance test more than anything, and that's kind of probably an easier way to start. Cool. Any other questions or anything? Want to watch funny cat videos? I'd be a little worried about trying to stream it through Link. All right. Great. I'm glad you guys liked it. I think a lot more people should know about this because I think it's really neat. You gotta thank Dave here. He's been helping out on this. Okay. Well, you've done some really cool stuff. I'm really interested to see how you did the code coverage stuff. I'm gonna dig into that a little bit this weekend, I think. Great. Yeah, and do it. Huh, interesting. Breakpoints. Wouldn't have thought of that. I figured the AST was involved somehow. Yeah, no problem. Thanks, guys, for coming.
All right, I've left the room, so I should be able to talk now without an echo. Can you hear me okay, Adam?
Yep, I can hear you great.
Okay, cool. That was really good, so thank you very much. That was, and the guys here liked it as well, so.
Good, great.
Very, very useful.
Glad to hear. Great.
Right, so what's next? I think we've got I'm having a look if we've got something to give away, actually. I think we've got a copy of Lee Holmes's book, and actually now is a good time to plug Adam's book as well, if you haven't read it. I can't remember the title though, Adam. What is it?
It was PowerShell 3 First Look. So it's a little outdated now. But
yeah.
I would honestly, if you're going to get a book, you get the PowerShell Deep Dives book. That's what I would suggest.
Ah, yeah. You've contributed to that as well, haven't you?
Yep. That one is full of some great stuff.
I'm trying to log into my OneDrive to check if we've got a copy of the book to give away. having all sorts of problems logging in. It's crazy. Right, at long last, I'm in. We do. We have free ebook voucher to give away. I'm not actually sure which one it's for. I'm pretty sure you can choose from a list of O'Reilly publications. So I guess what we'll do is we've captured everyone's name that's here. I won't hold people up and kind of work out a way to randomly select a winner. So we'll email out a voucher a little later, I think. That's probably quicker and easier. So, okay, so I guess a couple of other things to mention about the user group is we've got another Power Breakfast coming up at the beginning of next month. And next month as well will be the next PowerShell Saturday event as well. So we're not sure exactly when yet. We need to plan when that's actually going to be, but we'll email out over the next few weeks to let everyone know when the dates are. Stephen Morawski is actually up next on the meeting in August to talk about what he talks about pretty much everywhere, DSC. So
it'll be a good session though.
Yeah. He's pretty much the guy who's used it the most in the world, I think, isn't he?
Yeah, definitely. He was using it in production at Stack Overflow, I think.
Yeah, and he's actually changing jobs now as well, right? He's moving on to, is it Puppet or?
Yep. Well, I think it's Chef, actually. Right.
Yeah. So he'll be here next month talking about some of that. All right, so I think that's pretty much it for what we have today. So we've recorded this. All of the fluff that happened early on, I'm sure Milton can chop that out and he'll make it available online.
Cool.
Yeah. And the URL is there. But yeah, one more time. Adam, thank you very much. That was a lot of help to people here. And
thanks for having me on. Yeah.
I'll be looking more into it as well. So yeah, thank you very much.
Okay. Yeah, thank you. I appreciate you guys having me on here.
You're welcome.
Cool. All right.
Thanks, guys. Let's wrap up.
All right. Talk to you guys later.
Okay, take care. Bye.
All right. Bye.